Today's show is sponsored by Datadog. Start monitoring EC2, RDS, ECS, and all your other AWS services in minutes with Datadog. Whether you have 10 instances or 10,000, Datadog automatically tracks hosts as you scale. Visualize metrics, automatically alert on anomalies, and collaborate across teams to quickly troubleshoot issues before they escalate. Give it a try with a free 14-day trial by visiting datadog.com/cloudcast, and Datadog will send you a comfy, complimentary t-shirt. That's datadog.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everybody is doing well as we continue to roll through September 2020. Not a whole lot of new updates around the coronavirus and so forth. I think we're all still trying to stay safe. Hopefully you are taking care of yourself and your family and your colleagues and your coworkers and doing what you can to adapt to the new normal that we're living in. Let's go ahead and jump right to Cloud News of the Week. There are a couple of interesting things that are popping up on the cloud radar as we sort of get into that lull before some of the bigger cloud trade shows finish up the year for us. But first, news of the week is that GitHub announced that they are launching a public container registry. So with having Docker having sold some portion of the company over to Mirantis, continuing to run Docker Hub, they had recently made some changes to how they did pricing as well as how long they were going to keep images. And so that's opened up an opportunity for some of the other public repositories, public cloud registries that are out there. Obviously, there are a number in this space, things like Quay.io, Docker Hub still out there, but GitHub seems like a very logical place to be launching a container registry. They announced that Docker is the second most popular format they're seeing in packaging behind NPM for Node. So very interesting to see that happen. We've talked about this throughout the year. We continue to see GitHub as the place where developers are really seeing all their tools be put in one place, whether or not they're all being used or not. We're seeing GitHub Actions. We're seeing now GitHub Registry. We've seen a lot of other collaboration tools around GitHub. So GitHub continues to innovate around what developers want, what developers need. So interesting to watch that happen. The second piece of news we had this week was the annual Gartner Magic Quadrant for cloud infrastructure was announced. Not a whole lot of big changes from 2019 to 2020. Amazon did, at least in the eyes of the Gartner Magic Quadrant, extend their lead from Microsoft and Google. So there really is sort of two categories here. You have the leaders and you have niche players. Last year there were 6 that were in the space. There was AWS, Azure, Google. You also had IBM, Oracle, and Alibaba Cloud. This year the Tencent Cloud is added to the list. So we're now back up to 7. The two clouds predominantly in Asia, Tencent and Alibaba, both on the list, as well as AWS, Azure, Google, IBM, and Oracle. Oracle Cloud did sort of make a big jump from where they were in 2019, according to Gartner. Google and Microsoft seem to sort of a little bit stagnant in terms of the again, this is the the analysis by Gartner. It is sort of interesting to see, whether their analysis tracks revenue. That doesn't necessarily seem to be the case as much in terms of stagnance. We are seeing growth from Google. We are seeing growth from AWS. From Azure. And in some cases faster than AWS. But according to Gartner, AWS extended their lead. So for about the 10th year in a row, they continue to be the leader in cloud infrastructure. So always something we like to kind of track, as well as tracking revenues and other sort of key indicators. So with that, we're going to wrap up Cloud News of the Week, and we're going to get right to our interview. We have a fun discussion about what's going on in the Tensorflow community and what's going on in terms of Tensorflow beginning to be more popular and more widely used in the AI and ML community. So look forward to that right after the break. Today's show is sponsored by DivvyCloud. DivvyCloud protects cloud and container environments from policy violations, threats, IAM challenges, and misconfigurations. Types of misconfigurations that have cost enterprises a jaw-dropping $5 trillion over the last 2 years. DivvyCloud provides continuous security and compliance across all cloud service providers and containers, including AWS, GCP, Azure, Alibaba, and Kubernetes, providing a comprehensive view of what's in your cloud, along with the tools and automation you need to manage it today. DivvyCloud is proving that security and innovation are not mutually exclusive, one customer at a time. Join innovative enterprises like Spotify, Fannie Mae, and Discovery, who have found the freedom to innovate securely without loss of control. To learn more, visit divvycloud.com/cloudcast. That's DIVVYCLOUD.com/cloudcast to sign up for a free trial. DiviCloud. Find your freedom to innovate. And we're back. And folks, some of the times that we get a chance to really dive into some topics that we know that you've given us feedback on, that you want to learn more about, especially when they are, really kind of not only hot topics in terms of the technology, but things that more and more people are telling us, hey, we're starting to learn about this, we're curious about this space, and it's becoming more and more relevant to our business. We always love to dive a little deeper on that. And one of those topics that you've been really interested in is deep learning, AI and ML. Aaron's been hitting on some of those topics throughout the year. But we really want to kind of, dive a little deeper onto that, get a little more into it, and specifically kind of dive into Tensorflow, which is one of those topics that is really, especially if you're in the open source space, is taking up a lot of buzz, getting a lot of people excited, and we're seeing it continue to grow. So very, very excited to have Andres Rodriguez, who is a senior principal engineer at Intel, join us today. Andres, welcome to the show.
Thanks for inviting me.
Yeah, it's great to have you on. So you've got a kind of very interesting mix of background in terms of industry, government, academic work around machine learning and deep learning. Give folks a little bit of your background and what's really, makes you passionate about this space.
Yeah, it's been a fun ride working in academia and, as you mentioned, government and now in industry. And I've been working in different areas, all related to machine learning. I did some work in robotics. I focused on computer vision. Then I did some work with the government on using different types of sensory data to improve detection using deep learning algorithms. I work with, in academia, doing research to advance some of the performance of deep learning algorithms. And my current focus is on deep learning systems. So this involves working with data scientists that are developing new models, with hardware engineers that are designing the hardware that will run these models in a couple of years, and also with compiler or optimization engineers that take models and map them to run efficiently on a hardware backend. So working with all these types of engineers to develop a robust platform to meet Intel's customers' current needs and future needs.
Yeah, no, that's fantastic. It's always good to have guests who have kind of a really deep breadth of knowledge, not only from a usage perspective, having, like you said, you worked on it, trying to improve algorithms, but now really diving deep into it, at the point in which the software and the systems are interacting with hardware and optimizing around that. So great to have you on the show. Before we dive too deep, which I think we could probably do if we had the time, let's start a little higher up. Like I mentioned in the introduction, we're going to talk a little bit about Tensorflow, which is one of the most popular open source projects on GitHub. It was created by Google. Google published it out into the open source community a number of years ago. Let's sort of start with some basics. Help us kind of understand some of the types of data problems that TensorFlow is best designed to help solve. What are the types of things that data scientists might go into their toolbox and say, yep, I'm going to get started with TensorFlow because it's going to help me with this type of problem?
Yeah, certainly. So TensorFlow was released by Google, as you mentioned, probably around 5 years ago. And it is primarily designed to help data scientists develop, design, and train deep learning models and deploy them. So TensorFlow provides a number of tools to help in this area. And it abstracts many of the mathematical and implementation details. So for example, when you're training a model, you'll often have to prepare a data set and TensorFlow will have tools to help you, or has some extensions to help you prepare your data set. When you are starting a model, it has different functions that you can use to instantiate a model in different ways. When you are learning, or you are actually doing the training process, it does the computations of the changes that the model requires automatically for you. So those gets hidden, and the user doesn't have to worry about that. And also, TensorFlow runs on multiple hardware backends. So it runs on a CPU, on a GPU, on a TPU, and many hardware vendors are also working to incorporate TensorFlow support for their hardware. And so as a data scientist, you can use TensorFlow to take a model and train it and deploy it on a variety of hardware. So it abstracts to a certain degree the hardware backend. So it's been a great tool for the industry, and I believe it's the most popular framework for that's used in production, and it's adopted by several companies.
Yeah, that's a lot of what we had heard when we were kind of doing some research on this, and it's really interesting that it came out of Google, who's obviously world renowned for their expertise in neural networks and machine learning, and yet what this project has sort of become somewhat famous for, popular for, is the things that you said, which is simplifying so many of those things that would have been complicated or got in the way of for a data scientist, between them getting started and having to know all these things. That really helps simplify them. So it's great to see that be the driving force to get people started. As you dig into TensorFlow, you start to understand that it's focused on how data flows through graphs. It's explained as how it flows through graphs. What are some of the sort of common types of problems that people would use TensorFlow for? Is it is it image recognition? What is it when they talk about data flowing through graphs of nodes? What types of problems sort of fit that type of model, that learning model, or model, I guess, if you will?
Yeah. So first, to take a step back, a graph is just a set of computations. You can think of a graph with multiple nodes, and you can think of each node as an operation, and the edges that connects two nodes as data flow. So the output from one operation becomes the input into another operation. And graphs are a great way to represent neural network models. And so I would ask the question of what are deep learning algorithms typically used for? And for most of those algorithms, TensorFlow can be a great tool. And so the main types of algorithms that people use deep learning for are three categories. One is computer vision algorithms. And in fact, the resurgence in neural networks came in part because of a breakthrough in computer vision, where deep learning expert, actually a student with his advisor, or two students with their advisor, they enter a computer vision competition and got first place, beating many computer vision experts, even though computer vision wasn't their expertise. So they showed the power of neural networks. So computer vision is one, and I would say that computer vision is probably the one that has the widest adoption in the industry, because it's probably the most mature, and there are a lot of pre-trained models available and data sets available. Another area where deep learning gets used for is for language tasks. So where, for example, if you are translated from one language to another language, or if you are trying to determine whether a sentence or a paragraph or a document has a positive tone or a negative tone, or if you are generating speech from text or the opposite, generating text from speech. So all these language tasks, they can use deep learning models very effectively.
Interesting.
And the third main category of workloads that are used in production are recommenders or recommendation systems. Mm-hmm. So, for example, when you go to a social media company and they provide they recommend a news feed, or when you're purchasing a product in e-commerce and they recommend a product, these are using recommender systems. And so while I mentioned that computer vision probably have the widest adoption across the ecosystem, recommenders are the types of models that have probably the most monetization opportunities for companies. So large companies use recommender systems, and so they're very, very popular among what I would call like the hyperscaler companies, but they're not quite as adopted in academia, just because we don't have a lot of publicly available data sets at the scale that some of these hyperscalers have.
Yeah.
And so TensorFlow is used in all of these types of workloads. But I do want to mention something that a bit of the evolution of TensorFlow. So when TensorFlow was released, the first version, it focused on performance, and one of the ways it did this was by adopting what it's called a declarative programming style, meaning that you first declare the whole graph and then you compile it and run it. So this is also known as having a static graph. And this works well for many models, but some of the recent models require more control flow. And control flow was a bit tedious to do in the first version of TensorFlow. However, TensorFlow released a second version, and this version adds dynamic graphs. So this is also known as eager mode, and this allows, or this facilitates training and deploying models that have more complex control flow. In other words, that have more dynamic graphs. And so with TensorFlow version 2, the multiple a more broad set of workloads can be supported.
Yeah.
However, not everybody has yet transitioned to TensorFlow version 2, but I think it's to their advantage to be able to run dynamic models more easily.
Interesting. Yeah. No, it's very interesting that the use cases, or the types of use cases you highlight. If you think about like you said, computer vision, sort of things related to speech recognition and translation. I mean, those are very human interactions, or at least the output of those is very human interaction. So they're there to help kind of bridge that gap between, I assume it's going to be part of, how augmentation is for driving, whether it's complete, autonomous driving or sort of augmented driving. You think about the speech use cases could be everything from call centers to the devices we now have around our homes, the Alexas and OK Google type of devices and those things. But, the way that we interact with all sorts of stuff now with speech and, so you start to think about all those and you realize why we're seeing such a huge acceleration, because people are now very comfortable with, with the computer helping them in some way, whether it's through sight, whether it's through speech, whether it's through, reading things to them. We have audiobooks and all sorts of stuff. So it's really interesting to see that happen. And then, like you said, with version 2, it's now making the way that the models work more dynamic. And anytime we see that sort of jump, then you see a whole new set of interesting, creative ways that people are using the technology. So it was really kind of a great way for you to summarize what people are doing with them. And then you start to think about, in your day-to-day life, the things that are making it easier. And you go, oh, those types of models are behind what's making sort of that magic experience happen. That's very, very cool. We talked a little bit at the beginning, the work that you do now is a little more focused on working with some of the hardware teams like at Intel and others in how they're driving, more interaction here. Obviously, like you said, TensorFlow can run in a lot of different forms of hardware, whether it's, a laptop or, an standard sort of x86 server, Intel server, CPU-based server, can work on GPUs, can work on TPUs. Like at what point, what are some of the characteristics that you're thinking about and you're working with your teams on that really need that more advanced hardware integration, hardware acceleration? What are some of the kind of the pain points or some of the new capabilities that really need more intelligent understanding of the underlying hardware?
Yeah, so one of the building blocks of deep learning models is matrix multiplications, especially large matrix multiplications. And this operation can be easily parallelized across multiple cores. And not just matrix multiplication, but other operations like convolution and others can be parallelized across several cores. And so a characteristic of hardware that is good for deep learning is hardware that has some general purpose capabilities, but also some specialized compute. And as the models are growing in sizes, there is a need for specialized compute that particularly specializes in doing matrix multiplications. And so what Intel is doing is we are adding special instructions to our Intel Xeon processors. So we started adding instructions like AVX512 in Skylake, and we augmented those with what we call the deep learning boost in Cascade Lake, which was released last year, and this year we augmented those in the CPU we released called Cooper Lake. And the way we augmented these AVX512 instructions was by adding support for lower precision, so for int8 and bfloor16 multiplications. And what's unique about not unique, but what's helpful about deep learning models is that you can lower the precision of the model. So instead of having to do double precision with 32 bits, with 64 bits, you can go down to just 16 bits and have sufficient precision for training and inference. And actually, for some workloads, you can go down to 8 bits and not suffer any loss of accuracy. So deep learning models are robust to lower precision. And so we are adding in our hardware, and other hardware vendors are doing the same thing, adding support for 16-bit and 8-bit multiplies. In the next generation of CPUs that will release next year, which we call Sapphire Rapids, we are adding a special set of instructions called the Intel Advanced Matrix Extensions, or AMX, that significantly boosts the performance of bfloor 16 and int8 multiplies. So you can think of this as a set of systolic array-like multipliers that we are adding to our CPU cores, and they will result in higher training and inference performance. So this need for dedicated compute or specialized circuitry, we are adding to our CPUs, to our server CPUs.
Yeah.
In addition, we're also working with an accelerator team that Intel acquired called Habana, and they are developing also a specialized accelerator. So the CPU will have both general purpose compute and dedicated acceleration for deep learning, and that can support a broad set of workloads. But if a customer, an end user, just wants to primarily focus on a workload that is primarily just compute, then having a dedicated accelerator like the ones that our Habana team is developing might be preferable.
Yeah, no, that's great, and as always with Intel, it's it starts off as some of the early technologies, and then it becomes just part of the mainstream of the chipset that's in every server that people are using all over their data centers and in the cloud. So it'll be great to see that become more widely available, like you said, sort of later this year or early parts of next year. I want to dive a little bit into the software side of things. TensorFlow primarily works with Python as a language. There's plenty of people with some background in Python that are out there, whether they're on the infrastructure side of things or obviously data scientists. Beyond sort of some background with Python that people might have, what are some of the other kind of skills that are appropriate? Is it certain types of math? I know you talked about sort of matrix multiplication, but what are some of the things beyond Python that make people successful working with TensorFlow?
Yes, great question. So TensorFlow is actually written in C++, and it has a Python front end, but it has other front ends as well, even though Python is the most popular. So there are a number of other languages that can be used as a front end, and they're all maintained at different degrees of support. So you have languages like Swift, Julia, also C++. So you don't necessarily have to come in from the Python side to use TensorFlow. But to add to what you're asking on what is needed to getting started with TensorFlow, in addition to knowing Python or one of these other languages, I think having an understanding of different deep learning models is important. Understanding the basic blocks of deep learning models. So when you are building a model, you know what building blocks to choose, like different activations like ReLU, convolutions, fully connected layers, normalization layers, etc. And something that is often overlooked is how to design a model or a graph. I think we often just want to put a bunch of layers and a bunch of units in each layer, or neurons, as they're often called, and then start training. But if you start with a large model, then they're really, really hard to debug. So you often want to start with a small model, make sure that everything's working well, and then build it up to more and more complex models. So just having some understanding of how to design a model and how to work with the different components. For example, how do you initialize the weights of the models, and what learning algorithm do you use? So, for example, you have gradient descent, which is actually not necessarily recommended for deep learning, but it's one that people are familiar. But there are many variants of gradient descent that are useful for training deep learning models, like stochastic gradient descent with momentum, Adam, rectified Adam, Ranger, etc. And also, how do you debug a model? So when things are not working, maybe things are working well on training, but then when you are deploying it, the model's doing terrible. So how do you fix this? And I think that requires both reading about deep learning and also having some hands-on experience where you try things, you fail, and then you start improving.
Yep.
So I would say, just doing some of these things will help you. So in addition of knowing Python, having an understanding of how deep learning algorithms work, I think is critical to be successful.
Okay. And let me ask you one last question, kind of, as people think about, okay, what they've been learning, they've been sort of learning from you now for the duration of the show, and they're kind of curious about it. Do you find for people that are new to this space, are there any kind of, this is a good starting path? What are some of the good learning paths, or maybe some of the most commonly used tools or frameworks that people use to go experiment with this and start to get some experience and some learning? Have you found any, 2 or 3 that seem to work really well?
Yeah, well, what I would recommend if somebody's new is to first take a deep learning course. Intel offers one with TensorFlow exercises that you can Google it. Google also offers one, so find one that fits your learning style and do the exercises. Mm-hmm. Sometimes you can find courses that offer free cloud access, so you can actually run the models on the cloud, like Google Cloud. Mm-hmm. And then you can, once you learn the fundamentals, then you can experiment with some of the additional tools that TensorFlow has. So, for example, TensorFlow has a visualization tool called TensorBoard. So you can visualize the different layers of a model. It also has extensions or complementary libraries like TensorFlow Extended, which provides an end-to-end set of libraries that you can use to deploy deep learning models. So you can prepare the data set and then build it and train it on TensorFlow and deploy it using this larger TensorFlow Extended platform. And the types of extensions and tools that TensorFlow offers are quite extensive. So once you finish a basic course, experimenting with the many tools, depending on the task that you're working, will be beneficial. And I think you'll be pleased with all the tools that are at your disposal with TensorFlow, and in particular with TensorFlow version 2.
Yeah. No, that's outstanding, and like we said, it's always good to know that not only are there great tools out there, but like you said, there are some very good learning out there. Whether it's from Intel, Google has some, Coursera always has some, but the cloud providers also typically are going to have a lot of these things that you can now access through the free tiers and other things. So it's the great thing about open source is not only is the software out there now, but the tools and the things you need to get started are out there as well. So with that, I'm gonna kind of wrap it up. Andres, thank you so much for the time today. It's been great to just begin to scratch the surface on TensorFlow and your insight as to what's making it successful and where it's advancing has been great. Folks, I will point out, this is a topic that is really deep and really rich. We put a number of things into the show notes that you can go dig into, whether it's, kind of things about learning the technology, some of the work that Intel is doing to really advance it, some of the work that Google is doing around TPUs and other things. All of that is in the show notes. So definitely follow up on that as you're looking at the show notes. So with that, I want to once again thank Andres for his time today, for myself and for Aaron. We want to always thank you for listening, for telling a friend, for sharing the show with others and giving us feedback on Apple Podcasts and everywhere else that you get your podcasts. So with that, I'm going to wrap it up for today, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.